Welcome to Dr. Yap Van Ha's Problem Box. In today's lesson, we are going to solve a problem. Let's see what problem we have for today. The problem today is about a triangle. We know that this length is equal to that length. And for this triangle, we are going to fold it along this line. And this line is slanting at a certain angle to one of the sides of the triangle. We can fold it like so. The problem is, can we find that angle? The angle made by this line and that line, which are actually parts of the sides of the triangle before we folded it. If we know that angle, so we do know that angle, the value is given. We also know that angle, that value is given. Our problem today is this. Given this value and that value, how can we find the size of that angle? That's our problem for today. So given a triangle, and we know this length is equal to this length, and we know this angle, we also know that angle. The question is, can we find the value of this angle made by this line and that line? What kind of triangle is this? This length is equal to that length. You are right. This is an isosceles triangle. What do we know about isosceles triangle? Do we know anything about this angle compared to that angle? But do we know what the values are? Are they given? They are not. But can we find the values of those two angles given that angle? Next, we know the value of that angle. How does that help us? Is it helpful? Are we able to figure out the value of this angle? Remember, we know angles on a straight line adds up to 180 degrees if all the angles at that point on a straight line adds up to 180 degrees, and we know the value of that. Can you see how we can find the value of that angle? If we know the value of this from the second step and the value of that from the first step, can we find out the value of this angle? What's the answer? Why don't we put in some values? What if it is given that this angle is 68 degrees? And the other angle is 86 degrees. Can we calculate the required angle? This length and this length, they are equal. So that is an isosceles triangle. This angle and that angle, they are both equal. And they add up to 180 degrees. So that value and this value can be calculated, isn't it? By taking away that angle from 180 degrees, giving us 94 degrees as a total of these two angles. And because they are equal, dividing 94 degrees by 2 will give us the value of that. 47 degrees, isn't it? So we know that that is 47 degrees. We need to find out this angle. So we need to know that angle. What is that angle? There's a line here. Maybe we should add in a line here by drawing. So we know that that's 68 degrees. We do not know this. And we need to find out this. And this is a straight line, of course. What can we do? Is that right? Some of us are thinking that some angles are actually equal. Is there an angle that is as big as this angle? Is that right? Is it correct that this angle is also 68 degrees? Can you explain why that angle is equal to this angle? Is there a reason why they are equal? And if we know that that is also 68 degrees, can we find out that other angle? That's right. They add up to 180 degrees. These two, they are already 136 degrees. If these two adds up to 136 degrees, and the three angles add up to 180 degrees, what is that angle? And if we know that angle, and we know this angle, can we now find out that angle? Find today's problem easy, why don't you challenge yourself? One way to challenge ourselves is to solve for all other angles in this figure. The figure we got by folding the isosceles triangle. Given those information we know, the two angles, plus the fact that it is an isosceles triangle, can we find the angles, all other angles in this figure? Remember, whenever two lines cross, we get angles. And in this figure, we have many lines, hence many angles. We have so far found out that angle. 89 degrees, isn't it? Can we, for example, also find that angle? How about this angle? And for a matter of fact, how about all the other angles that we have in this folded figure? Another way to challenge yourself is to create a problem. Perhaps start with a rectangle. Fold it any way you like. And decide what values you want to give. Try to give as few values as possible. Hopefully one, at most two values for any of the angles in your figure. Of course, you can also start with a square or an equilateral triangle. That's another way we can challenge ourselves by posing what if problems. What if we have the same kind of problem, but we start with a rectangle, a square, an equilateral triangle? If you find today's problem easy, those are at least two ways you can challenge yourself. See you next time in another problem.